meteorology presentation. Yeah. So yeah, meteorology is just a DIV event. Our normal speaker today was unable to attend, so I'm going to present you the slides from them. So do my best to make a good presentation, but there might be a few information points that might be a little bit missed. But yeah, again, the questions just drop in the teams, and we'll have some of our experts always come in and help you guys. So let us get started. So yeah, here's just a little bit of rundown of what we're going to do. Just drill sheets, some difficult topics, common questions, tips from Reddit, and some other free resources. To start off with the real sheet, so there's some key topics in here. You got atmospheric structure, circulation patterns for either ocean and air. You got energy balance, climate zones, human impacts. You got the climate change, the past, the present, and the future. Don't forget also U.S. maps with state names. And also you have the U Chicago TM. So just a little bit some key points here is that you want to design your logs that they basically grant 3 points. You want to have like the most tested on topics, point distribution, so that you really know what to prioritize in terms of stuff. Because obviously you might not necessarily know what topics are going to be tested, but you can probably get past tests and exams from other other schools and that stuff. To just see, okay, what are some of the topics in here that, especially among these 6 topics, will really be commonly tested. And really, I think it's a good idea also to break down your notes on these 6 topics, just because I think it's a good way of structuring it. Also, we do have U.S. map with state names could be tested on the topics for you guys read the real sheet, but most likely it won't be tested, but still good to just have them just in case you forget them. And then also the rapid radio transfer model, which is the Chicago TM. Again, we'll share the slides so you guys can see the link later. So this one's really important. Because a bit of a practice exercise, you can play around with some of these parameters and stuff to learn. So like, for example, you could test how does surface temperature affect the rate at which planets gain or lose energy. And this can also help you kind of try to understand how each of the different parameters kind of affect the climate system. And the link for this U Chicago RTM simulation is in here. The RTM is a very important concept in meteorology, and sometimes people get kind of confusing with the rapid radio transfer model, and it happened to me too, and I took it, so totally okay if it gets confusing. All right, now for some difficult topics. Yeah. Oh, yeah. Before I get any further, can everyone online hear me in terms of some participation? Can everyone online hear me? Drop in the chat if you guys can hear me. Okay. Could you guys hear me before now or no? Okay, I will restart because I'm not sure if people could hear me before just now. So let us go back to the start. So, all right, we're doing meteorology here for Division B. It's only a Division B event, and it's part of a workshop series. Our original workshop host unfortunately could not make it today, so I'll be doing it instead. Yeah, and a little bit about me. I'm a scholar. I run a lot of stuff at GT Science Olympiad, and yeah, I did Science Olympiad back in middle school. It was a good time. I like the meteorology event. So yeah, if you have any questions, feel free to ask me. Yeah, let's get started. So just a quick rundown. We're gonna go through real sheet, difficult topics, common questions, tips from Reddit, and some other free resources. So going on the real sheet, some of the key topics we have are just going to be atmospheric structure, circulation patterns for ocean and air, energy balance, climate zones, human impacts, then climate change, so both past, present, and future, and also there's a US map of state names, and then the RTM, or the rapid radiative transfer model. So just some key points in here. I think some suggestions is I would look at some past tests and exams to kind of see the exact topic distribution for stuff, because that can kind of give you an idea of which topics you really want to put your notes to focus on. I would also put your notes, make sections for each of these topics. Just a good way of organization and easy access for stuff. Also, I know the US map of state names, it can kind of be like, oh, we remember the US states and all that stuff. But come on, sometimes on a test, you might forget them. You might get a little stressed. You might not remember them. So at least personally, I like to put it on there. Each person
It's allowed to do what they want to do, but I think it's just a good idea to do it as well. And then we will share the slides after this workshop, but with the U Chicago RTM, I included a link to a little simulation model made by U Chicago to show the rapid radiative transfer model. With it, you can kind of play around with different parameters at a time. So you can see stuff like how does surface temperature affect the rate of planet energy transfer. And with that, you can kind of see how different parameters affect the climate system. Yeah. Yeah, so we get into difficult topics. So the first difficult topic is just going to be ENSO, which is also known as El Nino or the Sudden Oscillation. It's also called La Nina. This is a recurring climate phenomenon where it changes sea surface temperatures, wind patterns, and precipitation around the Pacific Ocean. It occurs once every 3 to 7 years, and it can cause warming or cooling that's not typical in these areas from 1 to 3 degrees Celsius or 2 to 6 degrees Fahrenheit. The exact causes of it are unknown. But it's a really important topic and something that sometimes people don't really know well, especially because it's not something that happens in North America, it happens in the Pacific Ocean, but it's a big meteorology topic and you guys should definitely put time understanding it. Yeah, during the neutral phase, SST is warmer in the west and cooler in the east. Equatorial winds often blow east to west, also known as trade winds, and there's also heavy precipitation in the Western Pacific. So like with the heavy precipitation, again, I'm sure you guys probably know a little bit of this already. If you don't, it's okay. You've got plenty of time to still read up on it, but like, with like typhoons and that stuff, monsoon season, that kind of correlated with these patterns. During an El Nino phase, Eastern Pacific SST increases, which causes air to rise, which changes the pressure gradient. This pressure change disrupts trade winds, which could even cause them to reverse direction. And then there is less rain over the Western Pacific and more rain over the Central and Eastern Pacific. And during a La Nina phase, the Eastern Pacific SST decreases. The difference between the SST and air pressure in east towards west is even larger than normal. Trade winds are stronger when the pressure difference is greater, which leads to, in this case, stronger trade winds. And that means more rain over the Western Pacific and less rain over the Central and Eastern Pacific. And again, if any of these terms don't make sense, we'll show the slides later. And I would definitely go and study to understand these terms too, as well. So you guys can do the best on meteorology. Yeah, and then there's also a lot of other changes associated with this that aren't covered here, because after all, it is a really big topic, and there's a lot of literature out there. Definitely would recommend diving into this so you guys can be best prepared. Now, the topic number 2 is the energy budget. So with the energy budget, I think this is kind of a simple concept to somewhat understand, but also can get very easy to go into depth in terms of stuff. And it's just this concept that all energy involved in weather comes from the sun. So like energy that powers all living organisms and all that stuff, no matter what, just comes from the sun. The sun does this by emitting shortwave energy called like visible UV rays, and the Earth absorbs some of this energy and also re-emits it as long-wave radiation called infrared. And this long-wave radiation is not the same as light that reflects, but this energy is important because the energy that gets absorbed by the Earth is what's used for us to power the planet. Albedo is how reflective a surface is. Albedo of 0 means that the surface reflects all of, absorbs all incoming light, and albedo 1 means it reflects all incoming light, because either a source will either observe the light or will reflect it, and that's what albedo measures. So Earth has an average albedo of 0.3, which means about 30% of all sunlight is reflected back into space, which also then would mean that because we said 30% is reflected, the rest has to be absorbed, which means we have 70% that's absorbed by it. And this absorbed energy is which we re-emitted as long-wave radiation. This energy has left space, and then some of these gases too that are re-emitted by the Earth, they get absorbed in the atmosphere, the long-wave radiation, and they take some of this energy and re-emit it back to Earth as heat. This kind of creates that sort of greenhouse effect that can lead to some of the global warming and some of these things that you probably heard about in the news or you guys have seen from your studying. Yeah, and the greenhouse effect is really important for keeping the planet warm because it gets the heat and puts it back. But then also it can be harmful if it gets too much energy when it receives from the sun, because you want it to heat up the Earth only to the ideal temperature. You don't want to heat it up too much. Common greenhouse gases include water, carbon dioxide, methane, and nitrous oxide. Again, if none of these terms make sense, definitely go and do a deep dive later after we post the slides. So yeah. Now topic 3, as we talked, I mentioned the ozone layer. Let's go. We're going to talk a little bit about ozone. So ozone is just a triatomic oxygen, so also known as O3. It's something that's formed naturally in the stratosphere. So for the Earth, there's a few atmospheric layers on top of it. The closest one's the troposphere from 0 to 10 kilometers. Then you got the stratosphere, and then the closer area to the stratosphere, a little bit closer to the troposphere, is known as the ozone layer. And it kind of forms a protective layer around the Earth that absorbs harmful UV radiation. All right, yeah. Let me just make sure there's no questions on stuff too before I get too far. Okay, yeah. So, let's see. Where's my slides again? Here we go. Yeah, so stratospheric ozone is formed by the Chapman cycle. Ozone is formed when oxygen, O2, is broken into 2 separate oxygen atoms by UV radiation. And then these 2 separate atoms, at least one of them will then pair up with a non-broken oxygen atom to form ozone, which is O3. So because O plus O2 gets you 1 plus 2, 1 plus 2 gets you 3, and O3 is ozone. So that's how you kind of form ozone. And the ozone hole is one of the most important applications of ozone chemistry. So man-made chemicals called chlorofluorocarbon CFCs can destroy ozone. So actually, this fun thing about CFCs are they're like in your freezers and refrigerators. They're a very common thing actually used by us. And again, definitely spend some time doing a deep dive on these things. It's really fascinating, interesting after the presentation. And when CFCs are hit by UV radiation, a free chlorine atom is released. Chlorine can break apart O3 by stealing an oxygen atom. The chlorine atom can be reused for a long time, destroying lots of ozone. So it's like once the Cl breaks apart in O3, it's not done. The chloride can go and keep stealing oxygen atoms from multiple ozones. And these things can destroy the ozone in the ozone layer, and it can cause us to be exposed more to dangerous UV rays. And CFCs are actually regulated by the Montreal Protocol to help kind of reduce the use of CFCs. There's still a lot of use, but at least now that we know kind of some of the negative impacts, they're being more regulated. And this is causing the ozone hole to slowly heal, so that ozone layer can go back to being more full and be protecting us better. But progress obviously is not perfect, and it's only slowly happening. Okay, so now I'm going to do some common questions. So yeah, all the following questions have been pulled from our YJA website or Test Exchange on SciOly Wiki. Again, these are tools that you guys should probably know about. If you don't, we'll post the slides and you guys should look up these tools because these will help you get some good questions, because the best way to know what to put on your study sheets is to look at past tests, because you want to make your study sheets the best tools for your test. The best way to do that is by looking at past tests. So see question 1, what is the difference between weather and climate? I'll give you guys maybe 30 seconds or so to answer. If you guys want to put your answers in the chat too, that'd be great. That's muted. But I said I saw weather is short term in an area and climate's long term in a large area, and I think that's actually a really great answer. Only thing is the area thing is not necessarily true, but it's a really good answer. And it says weather, yeah, typically is follows short-term changes in the atmosphere, while climate focuses on long-term averages, typically greater than 30 years. And then if we go on to another question, it says label circulation cells, pressure builds, and prevailing winds on a diagram. This one will give you guys a little bit longer. I'll give you guys about a minute to 2 minutes to do it. Yeah, just maybe type done when you guys are done, and then I'll say around 2 to 3 minutes if you guys are done. Um, yeah, I'll just go ahead with the answer. All right, I see that you're done. So yeah, here's all the answers. So you can see here that you get the polar cell, you got the Ferrel cell, and the Hadley cell, and more the equator. And then yeah, you have the ITCZ, which is like the equatorial low. You have trade winds, subtropical high. You got the westerly winds, the subtropical low, or also known as the polar front. And then you got polar easterlies out there. And yeah, it's just again, for these things are like, oh, I can't memorize it. There's a reason you guys have cheat sheets that you're studying notes to put stuff on and types of stuff. Going on. It's labels, which of these items is also called the doldrums or the first latitudes. I'll give you guys like 30 seconds. Yeah. Again, if you guys are feeling like, oh, these times aren't that long, it's just a lot of these questions are just kind of like you know it or you don't in terms of stuff. Like obviously having more time always helps with stuff, but it's also like if you're not able to have access to the internet and you don't know it this in the first minute, I don't think this is like a question that you'll be able to figure out given more than a minute. So yeah, just kind of the thing with some of these test-based science Olympiad events where your cheat sheets are kind of really important for how you study for these events in terms of stuff. All right. So let's see the answer. Yeah, the doldrums are just gonna be the ITCZ, or the equatorial low, and the subtropical high is just the host latitudes. So, and again, if you don't know this, not a big deal. You study plenty of time before you guys have your regionals and that stuff, so don't stress. Now going on to the third question, it says the sun emits either shortwave/long-wave radiation, while Earth emits shortwave/long-wave radiation. I'll give you guys like 20 seconds. We did go over this, so hopefully you guys know the answer. If you don't, again, no big deal. Got plenty of time. But yeah, as you guys can see, the answer is gonna be shortwave radiation for the sun, long wave radiation for the Earth. The reason is because most of the light from the sun is visible light in UV, which has a short wavelength, while the light from the Earth is infrared radiation, which has a longer wavelength. Now we see here which of the following generally has the highest albedo. If you guys don't remember, albedo is just highest reflective property. The higher the albedo, the higher percent of light gets reflected by a surface. So yeah, I'll give you guys here about 30 seconds. So yeah, we see the gas of snow. Let's see. Yep, and that's correct. Fresh snow has albedo of 0.9, which means it reflects 90% of incoming light. And so you see here too, again, it's another one where it's like, oh, Um, it's another one where you kind of just either know it or you don't. And obviously, there's some of these where you can guess and get good intuition or check. But also it's just really do need to have a note sheet with all this stuff to make sure you know what you're going and doing. Let's see, not going. Question 4: which surface generally has the lowest albedo? If the question self-phrasing doesn't give you a hint, it's not guaranteed the surface has the lowest albedo all the time. So the answer to this one is the ocean. Has an albedo of around 0.1, which means it absorbs 90% of incoming light. That's definitely a little bit of a harder question, so definitely don't feel too bad if you don't know it. Yeah, now question 5. Which diagram represents El Nino and which represents La Nina? So actually, this one, the top one is El Nino because it has a warmer SST. So you see rain in the East Pacific is increasing, while rain in the West Pacific is decreasing. As you can kind of see here, drier sinking air too. And then you get rain for La Nina in the East Pacific is decreasing, while rain in the West Pacific is increasing, and you see a cooler SST for the bottom one. Again, if some of these diagrams are confusing, get time, study them. You'll be good. Don't stress. Definitely not too late. Now, question 6. Which phase of ENSO are we currently in, and what phase is predicted to occur next? I'll give you guys like another minute for this one too. So going on to this one. Yeah, check here. Yep, current neutral, great guess, and upcoming is going to be La Nina. So this is because the SATs here are kind of close to average. If you see these SST anomaly is close to 0, and then the overall trend though is also suggests of a decreasing SST, which suggests that La Nina is going to happen. And also, some of these colors and stuff are a little bit hard to see. Yeah, I am colorblind, so meteorology definitely was not the easiest event for myself. But yeah, hopefully you guys aren't colorblind, so they are a little bit easier to understand. But yeah, I'm going on to question 7. Which type of environment would produce this climatograph? Also, I'm sorry if I mispronounce some of these names. I'm not the best at pronouncing stuff. Yeah, give you guys another 30 seconds or so for this. Acetic acid are dry areas, desert areas, and wetlands. Yeah, it's actually hot desert. This is because there's a high temperature and there's no rainfall in these areas. So it's a hot desert. So desert is pretty close. And yeah, and also definitely I think the scoring depends for the event and if we get full points for saying desert versus saying hot desert, but I think you at least get some points for saying desert. And now some tips for weather, just for meteorology. If you guys get stuck on a tough conceptual question, try to break it down into the core concepts. Like for example, direction of flow is useful for questions that involve air or ocean circulation. Again, organize your notes, which is why I say going by those topics is so important because your notes are only as useful as your ability to actually search them and go through them. So make sure you have a good organization system that works for you with your notes so that when you're at the test, you're stressing, you guys can go and go boom, 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 and get your notes, find where they are, and find the exact thing. Learn vocabulary because a lot of these questions do use very specific climatology terms. For example, like SST is something that you guys were not going to understand half the questions if you didn't know what SST was. And then also be careful when using past tests to study because meteorology rotates topics. So make sure the test you're studying from have topics that are relevant to this year. Because you don't want to be studying stuff that came from 3 years ago and has no relevance to now. Because I mean, if you really like meteorology, I'm sure it's fun, but like it doesn't actually doing good in a test, probably not that useful. So make sure the topics you're looking at are the topics for this year, which is again why reading the real sheet is very important in terms of stuff. Always read the real sheet. Always read it. And yeah, so to that, there's additional resources that you guys can access when I release the slides. I'll be released the slides a little bit later, probably either Sunday or Monday. But I got NOAA jet stream, the introduction to climate science, UIUC online meteorology guide, and a NASA climate change website. Thank you guys so much. With that, if anyone has any questions, feel free to ask them in the chat, and I'll do my best at answering them.